Welcome, dear participants, to our online series Medium Voltage Technology Essentials. My name is Pedro Gomez. I work as a Product Lifecycle Manager for air-insulated medium voltage switchgears, and today I am here with my colleague Miriam Johansson, who works as a Product Lifecycle Manager for gas-insulated switchgears.
I would like to share my personal motivation for creating this training with you. I've been working for Siemens AG since 2017. As a mechanical engineer, I switched from the agricultural and construction equipment industry to medium voltage technology, with which I had hardly any contact at that time. I would have appreciated a compressed basic training when I started. So, I'm more than happy to welcome you to this series.
The Medium Voltage Technology Essentials series comprises 7 informative videos, organized into 3 comprehensive blocks. My colleagues and I will guide you through the topics of power supply, components of a medium voltage switchgear, design criteria, construction of a switchgear, our medium voltage portfolio, as well as the current topics of digitalization and sustainability.
Should you have any questions during our series, please do not hesitate to use the Q&A feature located in the upper right corner of this platform. We will ensure that each question receives a detailed response via mail after the event. If you are in full screen mode and cannot see the Q&A field for questions or the chat box, simply press the escape key to exit full screen mode. Now, enjoy your journey on improving your knowledge of medium voltage technology.
And to conclude with the words of the Chinese philosopher Laozi, learning is like rowing against the current. If you stop, you drift back.
Hello everyone and welcome back to our ongoing series on medium voltage technology essentials. Today we will focus on the digitalization of switchgear. In the previous sections you got already an overview about the Siemens AIS and GIS portfolio. Today I would like to present you the digital features which can be added to our classical conventional switchgear portfolio and can also contribute to the topic of sustainability, which was also presented in a previous section from my colleague Kartik. My name is Bernd Schüpferling and I'm the responsible Product Lifecycle Manager for digitalization, instrument transformers and secondary systems within our gas-isolated switchgear. Looking towards the future of our power distribution, we are committed to sustainability and digitalization. Maybe you ask yourself now the question, what has changed in the electrification and automation sector that I'm and almost everybody is actually talking about digitalization? An increasing number of e-car charging infrastructure, data centers, heat pumps and generally the decarbonization results in a rising energy demand. Together with the integration of more and more renewable energy supply with volatile generation, the transmission and distribution grids and the installed components are approaching more and more the limits. Therefore, an expansion and modification of the grid is unavoidable to ensure that the stability of the grid is still given and shutdowns will be prevented. As renewable energies have a volatile generation and also the energy demand for data centers and e-car charging infrastructure is volatile, digitalization is one of the main keys to ensure a trouble-free operation of the grids. Let's have a look on our digital solutions, which we are offering next to our classical medium voltage portfolio. Automation, protection and measurement have been integrated into our products for years, as well as communication applications. Basis for these offerings are our cProtec and cCam devices, which are widely installed in our switchgear and connected to control centers via standardized IEC communication protocols like IEC 61850 or IEC 60870-5-104. Remote FAT and services have become very important, especially during COVID times, where traveling was even not or only allowed with restrictions. We have expanded our offering very fast in these times, and it is used very well since then. Condition monitoring in combination with IoT applications is actually the most popular and most important digital offering. Installing sensors to verify the health status of the switchgear or to give a prediction for a necessary maintenance to prevent further failures and damages of the components provides a significant benefit to our customers. Today, we are focusing on monitoring, particularly condition monitoring in our gas-isolated switchgear. If we have a look on the architecture of our end-to-end monitoring solution, we have either in the switchgear or the substation level one centralized gateway from our CCAM A8000 RTU family. It collects all the sensor information either directly from the sensors or from intelligent devices like the C-Protect 5 protection relay or the CCAM FCM Plus fault indicator. Those monitoring functionalities are available either on-premise with a local HMI, in SCADA, or as a cloud-based IoT application, like the different feature sets of our Electrification X. We also offer so-called digital transformer substations as essential components of modern distribution grids. They offer the possibility of not only monitoring but also actively controlling grid components and are particularly important for increasing operating efficiency and reducing downtimes. A key component in this digital and also sustainable substation is our F-gas-free GIS ringmain unit 8DJH24 Blue GIS. The 8DJH24 Blue GIS, as well as all our other GIS switchgear, can optionally provide a condition monitoring to predict the health status of the switchgear, as well as a monitoring of grid operational data. Temperature and humidity monitoring can detect abnormal operating and ambient conditions. The circuit breaker can be monitored to prevent switching failures. Electrical insulation can become damaged over the time due to faulty or incorrectly installed peripheral components. As a consequence, partial discharge may occur. Our partial discharge monitoring system provides an early warning to avoid failures and damages on the switchgear. Gas density monitoring reports a warning in the very rare event of a gas loss. Last but not least, a load flow monitoring based on current and voltage sensors connected to an intelligent short circuit and earth fault directional indicator like our CCAM FCM Plus or a protection relay from our C-Protect 5 family can be integrated. Looking at the secondary GIS, especially our 8DJH24 Blue GIS. Digitalization involves so-called smart ringmain units. This slide here shows the devices and sensors integrated in our smart ringmain unit solution. Starting from the top, we have a minimum 200 mm low voltage compartment on top of the switchgear. To ensure an uninterruptible power supply, a battery buffer, for example in lead gate technology, along with a power supply and DC UPS module is a must. Depending on the available physical communication, the appropriate communication modem must be installed. To collect all the information from the switchgear and to receive all the control commands from remote, a centralized gateway like our CCAM A8000 RTU is mandatory. To control the motor of the 3-position switch, a motor control unit is installed which is not visible from the outside. In the ringmain unit cable feeders, there is typically installed an intelligent short circuit and earth fault indicator, such as our CCAM FCM or FCM Plus. Looking at the cable connection compartment, we have installed instrument transformers, mainly so-called LPITs, which means low power instrument transformers, for measuring the voltage and the current. These LPITs deliver analog signals, which will be converted into digital signals in the connected short circuit and earth fault indicator. These digital signals can then be transferred to the gateway and subsequently to the cloud or into the SCADA system. We have managed in the meanwhile also to integrate the current and voltage measuring in our cable connection bushing and released already the so-called C-bushing, which I will explain later in detail. If height restrictions in the compact substation do not allow the installation of the devices in the on top mounted low voltage compartment, there is also the option to install the gateway, UPS, communication modem and other components into a separate multi-purpose and automation box. This box is available as a standardized product in our portfolio and can be ordered optionally besides the ring main unit and be connected via standardized interfaces to the switchgear. Installation can be done, dependent on the substation design, either in a separate control compartment or on the low voltage side. As announced, I would like to explain now the C-bushing in detail. C-bushing combines current and voltage measuring in the cable connection bushing and avoid a project-specific configuration of external instrument transformers. C-bushing is a smart and intelligent cable connection bushing, type C, with an integrated Rogowski coil to measure the current and a capacitive divider to measure the voltage. Both are designed to the instrument transformer standard IEC 61869 and providing 22.5 mV at 50 Hz at 50 amps for the current measuring and a transition ratio of 10,000 to 1 for the voltage measuring. The measuring accuracy for voltage and current measuring is class 0.5. We have integrated an additional temperature sensor, which is used for compensating the voltage accuracy about the whole temperature range from -40 degrees to +115 degrees. This temperature sensor can also be used for further supervision of the cable connection and also to provide the temperature information via the short circuit indicator and the gateway into Electrification X for further use in different feature sets. Last but not least, we have the standard VDIS voltage divider integrated, which is used for verification of the absence or presence of the voltage. We are contributing also to the topic of sustainability with our innovative C-bushing. It provides massive material savings of iron, copper and cast resin, as its weight is only around 2.1 kg per piece compared with conventional CTs and VTs with a weight up to 50 kg per piece. Further simplification of the project execution is given due to the one-fits-all design. We have only one C-bushing for all voltage and current ratings in the factory stock, and also a later upgrade of grid parameters is possible without adjusting any component. Also, safety on site during commissioning and testing is higher due to low voltage outputs and no need of cabling or installing of instrument transformers around or on the cables. Digital secondary substations are using multifunctional short circuit and earth fault directional indicators like our CCAM FCM Plus, featuring directional sensing and protective algorithms. Together with the integrated LPITs into the C-bushing, it can indicate the fault and its direction. Furthermore, it provides up-to-date measured values of current, voltage, frequency, cosinus phi phase angle, as well as active and reactive power. These values are digitized in the device and provided via an integrated Modbus RTU interface for further use to a gateway in the substation. The connection of the C-bushing to the CCAM FCM Plus is realized with standard RJ45 connectors on the backside. Next to the measurement of current and voltage on the medium voltage side, a measurement of the currents from the low voltage distribution provides a more precise grid monitoring. In addition to new digital transformer substations, also existing ones are to be retrofitted easily with low voltage current measurement. The use of smart fuse links type Centron 3NA-COM is therefore useful for this purpose. This communication-capable fuse has the same dimension as a conventional fuse link and can be easily used in existing fuse bases. Thanks to its wireless communication, it involves no additional wiring effort for the data transfer to the gateway in the digital secondary substation. I already mentioned that retrofitting of already existing conventional transformer substations towards digital transformer substations should be possible with minimized efforts. Especially for the brownfield application, we are providing a gateway called CCAM EGS, which means Enhanced Grid Sensor, and could easily be mounted somewhere on the LV side in a conventional substation. It comes along with 3 Rogowski coils, which can be installed on the secondary side of the distribution transformer to measure the main current on the low voltage side. The already mentioned smart fuses could be also easily be retrofitted and connected via Zigbee to the EGS to provide the information about the outgoing currents. Voltage could be measured directly from the low voltage side with the EGS. Retrofitting of external low power CTs and VTs on the medium voltage ring main feeders together with the CCAM FCM gives transparency also about voltage and current from the medium voltage side. As the EGS is self-powered and provides an integrated LTE modem, connection to SCADA systems and/or to the cloud can be done with less efforts. The next slide shows the overall system architecture from the sensor to the cloud of a digital transformer substation. On the switchgear level, we have the smart fuses on the low voltage and the C-bushing with CCAM FCM Plus or external LPITs with CCAM FCM on the medium voltage side. A connection to SCADA via IEC 61850 or IEC 60870-5-104 and to the cloud via MQTT is established by means of a gateway, which could be either the CCAM EGS or the CCAM A8000. Let's have a more detailed look on the Electrification X, which is our IoT suite for electrification and automation. It is a software as a service offering to tackle the challenges of the energy transition with different feature sets like load management, network fault management, asset management, sustainable energy management, distribution grid management, and last but not least, OT companion for a continuous OT asset inventory and patch management. As already shown for the ATJH24 Blue GIS, as part of the digital transformer substation, we are also providing different monitoring functions with the help of sensors in our primary GIS. For example, in our ADAB family, which is our switchgear with the highest availability due to its single pole encapsulated design. Especially for the Electrification X feature set asset management, we have the following digital monitoring functions available. Temperature and humidity monitoring with PT1000 temperature sensors installed around the cable connectors and humidity sensors which can be installed within the switchgear and inside the switchgear room. Circuit breaker can be monitored with the I2T method with the help of the C-Protect 5 protection device. Further Hall sensors integrated in the low voltage compartment around the secondary wirings of the spring charge motor and the closing and opening coils, together with the CCAM FCM with breaker health monitoring function, are able to give a more reliable condition indication. Our in the low voltage compartment installed partial discharge monitoring device type Falcon unit receives its information from a high frequency current transformer installed in the cable connection compartment around all cable screens. The gas density monitoring requires digital gas pressure sensors per gas room connected to the A8000 gateway, where further analytic algorithms are implemented. Load flow monitoring can be provided based on current and voltage transformers connected to the protection relay from our C-Protect 5 family. In the past, current and voltages have mainly been measured using conventional current and voltage transformers. However, low power current and voltage transformers are becoming increasingly popular and offer significant advantages in terms of sustainability, material savings, and technical innovations, as explained already earlier. Low power voltage transformers are immune to grid disturbances, such as ferroresonance phenomena, and therefore do not require the use of damping resistors. Low power current transformers in Rogowski technology demonstrate linearity throughout the whole measuring range, even up to the full rated short circuit fault current without any saturation effects. For our NX Plus C 24 Blue GIS, we are able to provide also the C-bushing solution, as already shown in the ATGH24 Blue GIS. For the ATAB family, we have already available inner cone plug-in resistive voltage dividers for the bus bar and the feeders. Rogowski coil current sensors will also be available in the future to be connected to the 7SY82 Universal LPIT protection relay or to the IO241 module for further use on modular C-Protect 5 devices. To complete the digital solutions for our medium voltage portfolio, we can see here the monitoring solutions which we have available in our AIS portfolio. The parameters to be monitored are principally the same as in the GIS, except the gas monitoring, which is not relevant in AIS. Therefore, we are monitoring temperature, as continuous rising of temperature on critical points represents the majority of the failures. Also, loose connections and insufficient contacting can be detected with the temperature monitoring. Partial discharge can lead to catastrophic failures, and therefore a monitoring can provide an early indication of any degradation in the insulation. Circuit breaker monitoring can help to detect faulty vacuum circuit breaker components like trip coils, spring charge motors, but also can give a remaining operating lifetime prediction. Humidity monitoring is essentially in an AIS, as humidity and moisture are the two most important parameters influencing the degradation of the switchgear. It can also prevent condensation and corrosion, which might lead to mechanical and electrical failures. Last but not the least, we have also a LPIT solution available in our NX Air. Conventional CTs and VTs in AIS are designed typically as cast resin block types. To remain in the same switchgear design and to give the option to our customer to decide whether conventional or low power instrument transformers should be used, We replace the conventional CT with two small post insulators, remove the voltage transformers, and integrate a resistive divider and a Rogowski coil in the bushing. Between the circuit breaker and the cable connection compartment, LPITs offer a higher efficiency in transforming current and voltage without significant power losses, reduce energy consumption, and help to reduce CO2 emissions. The use of such technologies represents an important step towards a resource-saving and sustainable energy infrastructure. I hope you enjoyed the session about digitalization in our medium voltage switchgear, which could help to keep the grid stable, avoid shutdowns, and prevent that aging assets will fail. Looking towards the future of our power distribution, we are committed to sustainability and digitalization. Thank you for attending, stay curious, and look forward to our upcoming sessions.